Welcome to BKW Physics. I'm Mr. McConley, and today we're going to do standing waves. So if you focus your attention to the writing that's in black on the left-hand side of the board here, a standing wave is when you send a string of vibratory disturbances down a wave, or down a material, sorry, I said down a material, then it gets to the end of the material, and at the end of the material you have a fixed end. In other words, it's mounted to something pretty rigid. And then, as we know from our previous lessons, when you hit a rigid barrier or a fixed end, the wave will be reflected back. Part is transmitted, but very little of it is transmitted. Most of it's reflected, and the reflected part will be inverted. So what happens if you get the timing right, if you have proper timing, you can set up what's called a standing wave. And to anyone looking at it, it appears as though the material, let's say a slinky for instance, is both here and here at the same time. Now you know a wave or a slinky can't be in two places at the same time, so it's more of a visual illusion because this slinky is snapping back and forth. And to you, it's happening quick enough that it appears like the slinky is in both places at the same time. And it appears that it's in both places at the same time. But there are spots that it appears that the slinky isn't moving at all. So these things have names. The spots that appear not to be moving, like these spots right here, are called nodes. N-O-D-E-S. Nodes. Nodes are the points where the standing wave appears to be standing still. And the other three spots where the wave seems to be in two locations at once are called antinodes. Antinodes. So you have nodes and antinodes in a standing wave. Now let's be real clear what you need to produce a standing wave. What is necessary to have a standing wave happen? Well, the first thing that's necessary, as I mentioned earlier, is you need a fixed end. So first of all, you need a fixed end. Secondly, you need a constant amplitude. So the person producing the standing wave, or the source producing the standing wave, you can't be going big, small, big, small, big, small. It won't work. You need to have a constant amplitude. You need to have a fixed end. And lastly, you have to have some rhythm, what we call in physics a constant frequency. So you have to produce these waves with a constant frequency, a constant amplitude, and a fixed end. If you combine those three things, you will be able to produce a standing wave. So let's move to the blue. The blue is an example here. So this stick figure is shaking a slinky and producing a standing wave. This standing wave in total is 2.5 meters long. From here to the tree, this is supposed to be a tree. So this slinky is mounted to a tree, which is the fixed end, and it's 2.5 meters. And from trough to crest is 20 centimeters. So given that information, we can answer the three questions on the board. First of all, easiest one, what's the amplitude? Amplitude? A lot of people want to say 20 centimeters. Yeah, 20 centimeters. That's not correct. The amplitude, remember, is measured from the equilibrium position. And that's why I drew it this way, to try to confuse you or try to point out the fact that you got to go from the middle up or from the middle down. So our amplitude is only 10 centimeters. But it's perfect that you answered 20 because I wanted you to. And then the wavelength. The wavelength, remember, is you got to figure out how long does it take for the wave to repeat itself? And it gets a little more confusing with a standing wave because the pattern is like double. But if you start here, and you're kind of tracing along, by the time you get to here, your pattern is starting to repeat itself. You go again, here, and then there's some left over. So there's actually 1, 2.5 wavelengths represented here. And if there's 2.5 wavelengths represented here, how long is each wavelength? 1 meter. I think you can see that if this is a meter, and this is a meter, this is a half a meter, you add up to your 2.5, and so you have each wavelength being a meter long. How many nodes are there on this picture, just to test your knowledge of what you've just learned? So we go 1, 2, 3, 4, 5, and 6. There are 6 nodes on this. All right, to wrap this video up, we're going to head to the back of the room. We're actually going to produce a standing wave, hopefully.
Pretty sure that was
That's right. So in the video, can you see, you don't have to see me, but can you see the snaky somewhat?
Mm-hmm.
All right, good. So what I'm going to do is I'm going to start sending a constant frequency, a constant amplitude, and unnamed student number 1 at the end is a fixed end. Okay? So hopefully, that's not working that well. Let me try to do this. I'm going to take some slack out of it. I'm working way too hard to make this happen. So, you still holding tight? Oh, that's much better. Look at that. So when I tighten it up, I can actually produce a nice standing wave here. And right now, you can see that between the two ends is only 1 wavelength. Now, if I tighten it up even more, and shake it a little faster, it still wants to go to that. Oh, there you go. I got it for a second. You can see that I can actually produce standing waves of different multiples or different wavelengths. So for today, physics.